k-fold cross-validation. Why do you need validation and why in particular k-fold cross-validation? Let us see this. Previously, we had seen the use of training set, validation set and test set in a particular machine learning problem. While solving a problem, why should you initially have training set, validation set and test set? We had already discussed about that. Coming to validation set, there are two major uses. First thing is if you want to tune any hyperparameters. That is, we had seen, for example, during curve fitting and regularization, we had seen, let's say, regularization coefficient lambda. So this lambda used to control the effective complexity of the model. That is, how complex should your model be? That was controlled by lambda. And how did you determine this lambda? Using your validation set. The problem that occurs is not always would you have enough amount of data in order to do training, validation and then testing. What happens many times is you may have very less data that if you split it into, let's say, 80% to training, 10% to validation, 10% for test, then this 80 would become too less a quantity. Or let's say if you put into 60, 20, 20 and even larger problem. So in cases where data is scarce, which is actually in many real life scenarios, what you do, you use the technique of k-fold cross-validation. That is when supply of data for training and testing is limited. In this case, in order to determine the hyperparameters, what do you do? First thing you do is whatever be your available data, total data, you will split it into k different parts. That is, let us say this is your total data. You will split it into many parts. This will be totally k different parts. What is your next thing? The next thing you do is you divide it into two parts. One is testing and validation. For this, you'll keep it dynamic here, but the idea is like this. K minus 1 divided by k. This much of your data should be available for training. And 1 by k, the remaining 1 by k, this is what you will use for validation. This is the whole idea. So what you will do, k minus 1 by k, this will be the available data which is used for training and the data for validation. But here you will have this doubt that if I'm using only 1 by k for validation, isn't the validation data too small, right? So there is a small technique that you use here. That is, I'll show this in a table, then it will be very easy to understand. Let us say this is my table. Let us say this is my run 1, run 2, run 3 and run 4. And say I am splitting this into k different parts. This is my first part, second part, third part, fourth part, fifth part. Let's say these are totally k different parts. Here it is 5. Let us say k. What I will do is in the first run. So first run means only the top row. First time when I am running run 1, what I'll do, I'll take the first portion. First portion I'll keep it for validation and all the remaining things, this whole thing I'll use for training. This is during my first run. When I'm running the training the first time on the model, I'll train the model using this complete remaining part. Only the first part, k minus 1 of the parts I will use for training and the remaining one that I will use for validation. Then once I am done with this, I'll do a run 2. In the second run, what will I do? The second portion, this I'll keep for validation and the remaining k minus 1 portions, this much and this, the remaining k minus 1, I'll use all those for training. And in run 3, it is the third portion that I'll use for validation. Then fourth portion, then there will be one more run in which I'll use the final fifth portion. So here my k is 5. What happens here is, even though my data is less, even though I'm using only this much of data for validation in one run, effectively what I'm doing 5 different runs after dividing it into 5 different parts. Once I complete these 5 runs, what I'll do, once I repeat, that is, here the disadvantage is, instead of training once, I have to train k times. The whole training run, that has to be done k times. Run 1, run 2, run 3 and so on. Once I train the model k times, what do? I take an average of all these performances in order to identify its performance on validation set. Let's say I have a validation set that is initially validation set is this. I'll have a answer. Then I'll run on this validation set in the second run, this validation set on the third run, this on the fourth, and this on the fifth time. After this, I'll take average of all those and I'll validate my whole model on this data. So the advantage is that even though I had very less data, I was able to make use of complete data for training as well as complete data for validation. Even though I had to make multiple runs, I did make use of my complete data for training, complete data for validation without intermixing them. This is the whole idea of k-fold cross validation. It is important that you should make your model learn once, then again restart from the beginning. It's not a learning that you do on top of that. Okay. So here the process is like this. Initially you split data. Once you split, then you train. Once you train, then you evaluate and take an average. Okay. And where is this useful? It is useful in tuning hyperparameters. It is useful if you want to, let's say, compare different models. One more thing before we end this lecture, cross validation. It is of few types. I'll explain that as well. Cross validation. First thing is holdout cross validation. That is the normal validation that you do. We are not discussing much on that because here whole idea is about discussing k-fold. So second type of cross validation is k-fold. K-fold cross validation. That's what we just saw. That is, you divide the whole data into k different parts. Use k minus 1 by k of those parts for training, 1 by k for validation. Then you repeat this for k different runs. You average the value over all those runs. That is k-fold. What if your data is very less? That is, you don't even have enough data so that you have enough data in each of these k parts. Then what you do? You use leave one out validation. In this, what you do is your k is equal to n. N is the total number of data points. Your k you will choose as equal to n, which means for each of your runs, n minus 1 of your points will be used for training and only 1 point is used for validation. Only one particular observation, one particular point is used for validation. That is leave one out validation. Okay. And the last one is stratified cross validation. Stratified. Okay. What is the use of stratified? Here, previously when you divided data into k different parts, you took your data, randomly divided it into k parts. Okay. Now there is a possibility that, let's say it is some classification problem. Your data is 90% of one type and 10% of the second type. That is first class 90%, second class 10%. What happens if 90% is concentrated over here? That is, this much of your data is all of one class and last this much is of a different class. In that case, when you divide it into k different parts, first many parts will only have data of one class. Then the last one part will have data only of the other class. But this is actually biased data. In order to avoid that, in case of stratified cross validation, what you do, you ensure that each of your fold has the same class distribution as the original data set. That is the ratio of classes that is present in each of your k folds. All those folds should be same as that of the original data. So this gives you a bit more balanced analysis. So the different types are holdout, k-fold, leave one out, in which you take k is equal to n, and then stratified in which your distribution of data is same in all the k folds.